one of the greatest students of, he's still living after 100. He's now 101 years old.
Oh,
He is in
yeah,
USA. Recently, his 101 first birthday was celebrated by ISI actually.
oh, very good.
He's still mentally quite aware and still
Okay.
contributing at that age. He's one of the living legends of statistics.
Okay, yes. So now he is he at Calcutta or is he somewhere?
No, he's settled in USA.
Oh, acha.
Long back he has settled in USA.
Acha, can we sometimes, is it possible for him to just speak to give some lecture?
That I'm not sure, but I will inquire whether he's still giving lectures or something.
Some online, such a person, if he gives, that is a great privilege for all of us to listen to his each and every word.
Or at least we can have him as our chief guest in some program. He speaks for 5-10 minutes. I think that will be enough.
Good enough. Seeing him itself is a great fortune.
Right.
Yeah. So shall we start formally?
Yeah, please.
Okay. So
Halder sir, just one second. Requesting system administrator to kindly start YouTube live, please. Yeah, Halder sir, please.
Yeah. So good afternoon to you all, so dignitaries. It's my pleasure indeed to welcome Professor G. Singaya, Honorable Campus in Charge, Nehu Dura Campus, and Professor Kuntal Ghosh from Indian Statistical Institute, Kolkata, my other faculty colleagues from Northeastern University, affiliated colleges, my dear students, and other dignitaries present here. It's indeed my great pleasure to welcome and organize this event on behalf of Northeastern University Tura campus to celebrate National Science Day. So we are really grateful to our Honorable VC Sir, Professor P.S. Shukla Sir, for his kind support and enthusiastic leadership quality he has shown at giving extended all kind of support towards the development of the campus and university. And also all the time for organizing such events like this today. In fact, I initiated the program in very short notice, whereas really kind enough to extend all possible support and he always says that yes, please go ahead. Okay. With this, I just want to mention that today we are celebrating nationwide the National Day, 28th February. So 28th February, in every year it is celebrated as National Science Day to commemorate the discovery of Raman effect. Okay, Professor C.V. Raman was the great scientist and physicist who discovered the Raman effect in 1928, and for his he got the Nobel Prize also in 1930. So basically the history of this National Science Day was like this, that National Council of Science and Technology Commission approached the central government in 1986 to designate 28th February as a National Science Day. The government accepted the proposal, with the first National Science Day being celebrated on February 28, 1987. The purpose of the National Science Day is to encourage Indian youth to develop interest in science and understanding its importance. On this particular day, students and scientists from the country demonstrates their scientific projects, innovations, and state-of-the-art development using science and technology. This year, in 2022, the National Science Day 2022 theme is Integrated Approach in Science and Technology for Sustainable Future is the theme for this year. Okay. talking about little glimpse of Raman effect. Raman scattering or Raman effect is a spectroscopic phenomena discovered by Raman while working at Indian Association of Cultivation of Science laboratory. And effect describes how wavelength of light scatters when deflect on a particular object. I think Professor Ghosh will elaborate on these topics and elaborate the development of science. Science has developed a lot through this, a continuous process. So with this brief introduction, I welcome Professor Ghosh in our virtual meeting to celebrate the National Science Day. And before I formally invite Professor Kuntal Ghosh to deliver his lecture, I'd like to request our campus in charge, sir, Professor G. Singaya, to say a few words to welcome the gathering. Sir, over to you.
Okay. Namaskar to all of you.
No.
Our Honorable Vice Chancellor, Sir, Professor Prabhashankar Shukla, Sir, and our beloved learned colleague, Professor Kuntal Ghosh ji, and organizers, especially Dr. Arindam Haldar, Dr. D. Bhagat, and all the heads of the departments, all colleagues and principals of various colleges, students from different colleges, and all the people who have a real passion for this National Science Day, because for everybody, I really feel happy that all of you have joined in this program. And as far as I also joined with my colleague, Dr. Ananda Haldar, to welcome you all to this National Science Day 2022. The topic that is chosen for this year National Science Day is integrated approach in science and technology for a sustainable future. This is a very, very pertinent and relevant topic as on today, where our government of India is also emphasizing about integrated approach, blending of science and technology with various other disciplines. Accordingly, only now under our new educational policy 2020, we have also the government is also insisting multidisciplinary approach and interdisciplinary approach also. We have to adopt in our content and curriculum in all programs. That is so. In the same line, this integrated approach in science and technology for a sustainable future, we all have to rethink and introspect. There is what I understand, I am not a science student, but as a management student, there is a significant innovations, developments in the area of science and technology. Accordingly, our the national growth, development, as well as GDP, per capita income, and surplus production of various basic products, convenience products, specialty products, and luxurious products have also gone up. And there is also a lot of interdependency across the globe. Various nations of globe has also increased. Even our country has also been putting its best efforts to exchange our science and technology to different parts of the world. That way, India, since the great sons of our country, Professor C.V. Raman, he has become a pioneer as far as these innovations of the science and technology is concerned. And what all more important is that my understanding like this, the science and technology should always take into consideration the indigenous science and technology, indigenous knowledge and wisdom. That is also very, very important. When you blend the indigenous knowledge and wisdom, science and technology, with the modern science and technology, we are able to do miracles across the globe, where that kind of technology will really achieve the mission and objective of sustainability in the future. So that is why, especially you take, for example, in Northeast India, the Green Revolution had come up long back, but even today, the common man, illiterate man, they always question the relevance of application of fertilizers and pesticides. They must be convinced whether it is going to help the fertility of the land and whether it is going to really safeguard the health of the people who are consuming those products. So that much wisdom that is there very much in Northeast India, where other parts of the people, once they are told this is going to increase your yield, this will make you to earn more profit, people will immediately adopt, and that is why there is a degradation of land fertility and ecological problems that are emerging. The climate change also, to I don't know, to some extent that may be also responsible. That is why even in the area of medicine, I know one doctor cardiologist who was successful in cardiology in Western country, America, who has very much influenced by our Ayurvedic. He has been blending both allopathy and Ayurvedic, and he is doing wonders how to really sustainable health, health and social health, physical health and mental health. So that way, there is a strong need to interact and understand between different disciplines, because even various local language or traditions or customs, rituals, they have their own indigenous knowledge and wisdom, where mental peace, mental health, that is very much relevant, and the social health, community health, all these things are depending on it. That is why especially we being students and teachers and researchers of our country, our institutions, we need to relook and we need to revisit, reinvent various traditional knowledge of our science and technology of our ancestors, and we should try to integrate and modern research that is initiated by various departments, science and technology departments, as well as social science departments, humanities, management. We all have to work together. Then the real objective and mission of this National Science Day 2022, it will be realized that is an integrated approach in science and technology. So the scientific temper, which is it is even Northeast, people may believe that this is to be improved, but practically people have their own areas of expertise in the area of science and technology, and they are still either not only human values, the ecology, this forestry, water, and human relations, everything that are being maintained because they have. But now the modern science and technology should reach out to the common man, various grassroots level. We have to understand, and we should start conducting a research on how to blend and how to, through convergence, how we can come out with a innovative ideas, innovative thoughts, which will fulfill our sustainable development, sustainable growth. So that way, I hope I really appreciate Dr. Anandama Haldar, who has initiated at the 11th hour to organize this very fascinated topic on integrated approach in science and technology for a sustainable future. So that is a very great, and I really express my sincere thanks and appreciation to Dr. Professor Kuntal Ghoshji, who has accepted our request and who is going to deliver a talk on this very relevant and evergreen topic of this kind. With this, once again, I sincerely thank all the organizers, all the participants, principals or heads of the department, teachers, students, research scholars, and other people who have a passion for listening to this kind of topic. With this, Kublai, Mitela, thank you, Namaskar, Jai Hind. Thank you all.
Thank you, sir. Professor Singh, sir. Really, he has given an insight of the importance of science and technology to the practical field as far as our India needs actually and the world demands. So with this enlightening word, really, it will encourage our young researchers to work in the direction. And I'm really thankful, sir, for your kind words. With this, I now welcome Professor Kuntal Ghosh, the keynote speaker for today, to deliver his lecture. Over to you, sir, Professor Ghosh.
Was my screen visible when I showed it to you?
Yeah, it was visible. Yeah,
okay,
it was
so
visible.
I'm uploading it again. Okay. So a very good afternoon to you all. So thank you for giving me this opportunity on this auspicious occasion of the National Science Day to present before this august audience of Northeastern Hill University. And I thank the Pro-Vice Chancellor, the Vice Chancellor, Dr. Anindo Haldar, all the dignitary faculties present, and my best wishes to all other teachers and students on this Science Day. And the topic that I am going to present, though is related to the integrated approach of science, as is the theme of National Science Day, is also a bit different in a sense that here we are integrating, as you can see from the title of my talk, we are integrating science with the mode in which we talk about various civilizations in history. When we say rise and fall, it reminds us the rise and fall of Roman Empire. It reminds us of the rise and fall of the Mughal dynasty, and so on and so forth. So this historical approach to science, integrating science with history, integrating science with history's terminologies, is the goal of today's lecture. And through these, we shall try to arrive, hopefully, at the end of this talk, at an integrated approach of science and society. The Pro-Vice Chancellor, sir, was rightly talking about this integrated approach being taken these days, not only by the scientists, not only by the academicians, even the policymakers. He was referring to the national education policy. I will come to it towards the end of my talk. And I will try to explain why I have chosen this title in the mode of history as the rise and fall of science. What is there to talk about rise and what is there to talk about the fall of science? I'm particularly grateful to my PhD supervisor and teacher, Professor Kamlesh Bhaumik, whom I'm acknowledging here, for providing me a lot of content of this lecture. It was a short notice from Dr. Anindo Haldar, and I had to seek the help of my supervisor, My PhD days were long back, but he's a very knowledgeable and learned man, my teacher, and I owe him a lot, whatever I have been able to do today. As always, he has come to my rescue this time also, and I thank you, sir, Professor Bhomik, and I begin my today's lecture. So, since I am addressing an august audience that comprises of students, I am particularly trying to address the students in this lecture because they are the futures of this country. So I'm sort of asking several questions before the students, and since this is a virtual lecture, I will not wait for their answers. I'll try to provide the answers myself, but it will be in a sort of question answering mode, a lot of my slides. So during the last 50 years, which country has fostered maximum number of scientific discoveries? If I ask this question, so I'm sure that many of my students present here would say, of course, it is the United States of America. And right, they are. So let us slightly change the original question. Let us go beyond the last 50 years, a little bit more in the past, and let us ask, which countries dominated science during the first half of the 20th century, say before the Second World War? I'm sure many of my students would give an apt reply to these again. You are right. These are the European countries. United Kingdom, which ruled over our country for 190 years, France, Germany, which also had a lot of colonies here and there all over the world, and Netherlands among these European countries. And USA was almost nowhere during those 50 years. So this is a very peculiar observation, that in the first half of the 20th century, there were very few US discoveries, but in the latter half of the 20th century, it was USA who was making the maximum number of scientific discoveries. How do we fathom this? How do we measure this? Well, Nobel Prize can be one yardstick to measure this. We know it started from 1901. All my slides are properly visible, right? Whatever I'm changing my slides.
Yes, sir. Yes, sir. Visible.
Thank you. Thank you. So from 1901, this Nobel Prize started in memory of Sir Alfred Nobel, and it was awarded to important contributions in physics, chemistry, and physiology or medicine. So physics, chemistry, biology are the three important things on which Nobel Prize focused on. There were, of course, literature and other things, peace prizes and other things also. But since today we are talking about science, we'll concentrate on these issues. And through this yardstick, we are trying to measure the discoveries that I talked of right now. So let us see. We said that in the first half of the 20th century, USA was almost nowhere, and it were the European countries which were mostly dominating science through its discoveries. So to name only a few, Röntgen, the famous discoverer of the X-ray, we all know the X-rays, so famous now for our orthopedic surgeries. It is a essentiality, very, very indispensable thing, right? That was Röntgen winning the Nobel Prize. He belonged to Germany in 1901. Ronald Ross, he was born in India, right? We all know his name. Did famous work on malaria. He won the Nobel Prize. He was British, and he finally shifted to England for his studies. After being born in Almora in our country, we were a British colony at that time. So Ross won the Nobel Prize in 1902, belonged to UK. Arrhenius, the famous chemist, won the Nobel Prize from Sweden. That was in 1903. In the same year, three scientists together won the Nobel Prize in Physics from France. Henri Becquerel, Curie, and the famous Madame Curie, wife of Pierre Curie. So they won the Nobel Prize in 1903. Of course, Madame Curie originally belonged not to France, but that was also the different part of Europe. She was a Polish actually. So, but she shifted to France and stayed back with France. And here we can see some of the pictures. Those I have written in bold, there are pictures of those scientists here. So on the leftmost picture, you see the great Madame Curie, who not only won the Nobel Prize in Physics, but she went on to win another Nobel Prize in Chemistry. And that was much later. Then we can, Lord Rayleigh, the famous physicist from England, won the Nobel Prize in 1904. Thomson, another great discovery in the world in the atomic world, that was also from England. Golgi and Kayal, they made pioneering contribution in physiology and medicine. Why are they so famous? That is the picture. The second picture from the left is of Ramon Kayal from Spain, and Golgi was from Italy. They won the Nobel Prize because they discovered the neuron. Neuron is the nerve cell through using which I'm talking now, using which you are listening to me now. That was a mystery to the people, how we talk, how we see, how we smell, how we respond to information, how we process information, how the human brain does this. So that was a great discovery. It solved the mystery of the brain and the nervous system to a large extent. So that was Ramon Kayal, who together with Golgi, Camillo Golgi of Italy, won the Nobel Prize in Physiology or Medicine in 1906. So Spain and Italy. Then again England, Rutherford, 1908. Then again Italy, Marconi. And this prize maybe could have come to India also. The great J.C. Bose. They were working in the same domain. Our Professor Jagadish Chandra Bose in the British colonized India was also working in wireless telegraphy. And so was Marconi. Wireless transmission, Jagadish Chandra Bose achieved. But for reasons well explained in history, it was Marconi who finally won the Nobel Prize. But Jagadish Chandra Bose's contribution was no mean a contribution. Even now, this 5G technology that is going to come all over the world and in India is based on millimeter electromagnetic waves. And it was J.C. Bose who was the pioneer among all scientists of the world to work in these millimeter waves, which is now going to bring us the 5G technology. Anyway, so, but Marconi was from Italy, who settled in England. When I use the comma, it means he's originated from Italy, settled in a different country, but it was Europe all around. Van der Waals, Netherlands, we know about Van der Waals forces. When we were in class 7 or 8, we talked about the ideal gas equation, PV is equal to nRT. Van der Waals tried to draw up the real gas equation, right? So Van der Waals, 1910, Bragg worked on the structure of matter. So crystals, structure of crystals. So Bragg won the Nobel Prize from England in 1915. Then came all these great scientists of the modern physics. First Max Planck from Germany, 1918. Nernst, the great chemistry, who introduced the concept of chemical potential, chemical equilibrium. He was from Germany in 1920. Again Germany, Einstein won the Nobel Prize for photoelectricity. Bohr, Niels Bohr, he won the Nobel Prize for the stationary atomic orbitals. That means you can't jump, electrons can't jump from any energy level to any energy level, but there are some discrete energy levels. So quantum mechanics was going on now. So Denmark, all European countries. Here is one, C.V. Raman, whom we are celebrating today. The discovery of the Raman effect, the discovery of the Raman scattering, that was in 1930. That was from India. One exception I'm showing here, and I enlarged that picture because we are celebrating the discovery today. And then Dirac, 1933, again from England, UK, United Kingdom, the great quantum mechanics, Dirac. And I'm ending up, because now the Second World War is approaching, so I'm ending up with Madame Curie's daughter, Irene Curie, who, along with his husband, Frederick Joliot, discovered what is known as artificial radioactivity. That means they could construct such elements, they could construct such chemicals in their laboratory which were radioactive. That is, they didn't, unlike Madame Curie, who extracted radioactive elements from pitchblende, from nature. Here, her daughter, her son-in-law were synthesizing laboratory-made radioactivity. So I'm ending here this long list. I could have gone on with many more. We can see some of the pictures from, I showed you up to Raman, second from left. The third from left is Max Planck. Einstein, you all know. Then Niels Bohr, then C.V. Raman, and then Irene Curie. These are some of the pictures I'm showing you. So all these Nobel Prizes from 1901 to 1935 show a huge dominance of Europe, with USA almost nowhere. Almost nowhere. If you go to the Nobel Prize website, you'll find that. From 1901 to 1942, therefore, very few prizes went to USA. Only after the Second World War, USA suddenly jumped and they become the leader in science. So there was a rise in Europe, there was a fall in Europe. Now there is a rise in USA. And today we are analyzing the rise and fall of science. So let us see some of the Nobel Prizes after the Second World War, which mostly belong to USA, hugely belong to USA. We start with Wolfgang Pauli. Now this Pauli's exclusion principle, we all have studied. Pauli belonged originally to Austria, settled in USA. Now this is an interesting trend coming up. So not all US scientists who won Nobel Prize after the Second World War were actually originally US born. Of course, there were people like Richard Feynman, the centered person, the third one from right, or the fourth one from left, that is Richard Feynman. He belonged originally to USA, but not all. For example, Pauli was not born in USA. He was born in Austria. Then Bloch, he was originally born in Switzerland. He had to run for his life during the Second World War. The anti-Jewish repression came up, led by Adolf Hitler. And a lot of scientists had to flee from Europe, particularly with Jewish background. And they had to take refuge in other countries of the world. And US was one of them. Bloch was one such scientist who won the Nobel Prize in 1952. He belonged to Switzerland. Now he was USA. The great Linus Pauling, whose picture we can see on the left, who contributed superbly to chemical bonding. Linus Pauling's contribution was to chemical bonding. And Linus Pauling won another, I would request you to remember this picture, because Linus Pauling won another Nobel Prize about 10 years later, and that was a Nobel Prize in Peace. This is a very important example. A scientist winning Nobel Prize for his own subject in chemistry, and the same scientist a decade later goes on to win the Nobel Prize for Peace. And I will come to this issue of Linus Pauling towards the end of my lecture. Shockley, as we all know, was one of the originators of semiconductor physics. All these wonders of semiconductor physics, all these laptop I am using now, the mobile phones you are all using, that would never have been possible without the discoveries of Shockley and Brattain. The two names I can show you here. Shockley, settled in USA, 1956 Nobel Prize. Brattain, China-born, settled in USA, 1956. Like our India being a colony of the British, China was also colonized by several of the foreign countries. And Britain was born in China, just as Ronald Ross was born in India as a part of British colony. So same thing happened for Britain. So they were the originators of semiconductor theory. Mosbar, who contributed greatly to understanding the inside of the nucleus. Okay, he belonged originally to Germany, but then settled in USA. It was in 1961, and this is it was the greatness of Richard Feynman. We can see Mosbar's picture after Linus Pauling. This Mosbar in 1960, he did fantastic work on this Mosbar effect, what came to be later known as the Mosbar effect, in his PhD thesis. And Richard Feynman was aware of that, and he immediately invited Mosbar to come to USA. And Mosbar accepted that offer and came to USA, and he won the Nobel Prize in 1961 when he was already a second citizen of USA. Okay, so Mosbar, 1961, in 1960 he shifted actually from Germany to USA. Watson and Crick, we all know them as the originators of the structure of the DNA molecule, the origin of life, the origin of the gene. So Watson and Crick, we can see Watson's picture after Mosbar, third from left, USA. Another US person who shifted from Hungary, the great particle physicist Wigner. 1963, he won the Nobel Prize from USA, originated from Hungary. Richard Feynman, the next person in the picture, fourth from left. We all know his fantastic contribution to particle physics, especially quantum electrodynamics. Richard Feynman won the Nobel Prize in 1965. Then the well-known BCS theory of superconductivity. Barden, Cooper, and Schrieffer, all from USA, 1972 Nobel laureates. Weinberg, Abdus Salam and Weinberg. Abdus Salam's origin, you can consider India, you can consider it as Pakistan, because that was undivided India where he was born, latter which belonged to Pakistan. Together, these people made great contribution in unifying the nuclear forces and electromagnetic forces. It is called electroweak theory. They unified some elements of radioactivity with electromagnetic wave theory. Just as many centuries ago, when there was no Nobel, Maxwell unified electricity and magnetism. Weinberg unified electricity, magnetism, and nuclear radioactivity. So that was Weinberg. That is the fifth from the left. Okay, that is Weinberg. And last, another supposed to be Indian, but he was in USA. Again, when he won the Nobel Prize, Chandrasekhar, his great work on the stars, on the origin and development of the stars, right? So Chandrasekhar, again, he can be considered an Indian, can be considered a Pakistan-born, because he was born originally in Lahore, and then he became a US citizen and won the Nobel Prize in 1983. So post Second World War, during the Cold War period, there was a lot of domination by these US science in winning the Nobel Prize, which was not there pre-Second World War. However, US was not the only one who was winning Nobel Prizes at that time. There were other countries. Particularly noteworthy to mention is also the contribution of USSR at that time. During the Cold War, USSR, we know, they were the first to send Yuri Gagarin to space. So there was a Cold War going on, there was a space war going on, everything was going on, and great scientists were being born in USSR also. USSR, while a lot of scientists shifted from Europe to USA, and USA fostered them, gave them places. In USSR, it was a different story. After the Tsarist regime ended, it was a different regime there, the socialist regime under the Communist Party of USSR. And these people like Semenov in 1956 in chemistry, Cherenkov, the great physicist, and Tam, they won because of the Cherenkov radiation. That was a fantastic contribution to science. It showed today what we know. We know that every particle, the highest velocity attained by any particle is the speed of light, right? Cherenkov showed that that also depends on medium. There may be certain medium where a particle may be faster than light. That means the particle's velocity in vacuum is less than the particle's velocity in that medium. And if that occurs, then a peculiar radiation comes up. And that was known as the Cherenkov radiation. The two great Soviet scientists, Cherenkov and Tam. Cherenkov is the one from the left, the first one from the left. They won the Nobel Prize from USSR in 1958. Then the great physicist, Landau, who won the Nobel Prize for the low temperature physics, condensed matter physics, particularly on his theory on liquid helium. And then another great Soviet scientist won Nobel Prize in 1978, whose name is Kapitsa, also in low temperature physics, great contributions in low temperature physics. So while USA was doing the major discoveries, USSR was also not lagging behind. USSR was also contributing during that domain. Now, so from 16th to 19th century, Europe was the world leader in science that we all know, right? We know about the contributions of Lavoisier, Laplace from France, of course, the great Isaac Newton from Britain. So during the 16th to 19th century, it was not only before the Second World War, for 3 full decades, it was Europe which was the world leader in science. And there was a time even when even England was lagging far behind. France was much more ahead. And people used to say that how can a journal come up in English? All scientific journals are in French. So if you want to write an article, you have to learn French first, because all great science were from France. All the great journals were written in French language. Today, we can't even think of that. When we think of a scientific journal, they're all written in English. But there was a time in Europe during the 16th to 19th century, particularly early 16th century, when there was no journal in English. Everything was in French. And you have to learn French if you have to write a scientific article. But then the Royal Society came up. Britain also came forward. But ultimately, it was France, Germany, Britain. These are the countries which dominated science. And US was not even constitutionally organized as a state during that period. But then again, the question comes that what was it before the 16th century? Did Europe always have this scientific temperament? If I ask my students here, was it the same before the 16th century? 16th century, it was the rise in science, right? Then fall in science, USA coming up. To some extent, USSR also. But before 16th century, was there a separate rise in science? Yes. Europe was not the leader of science before 16th century. In fact, what I have written very specifically, Europe never had any trace of science for a few centuries before that. Quite a few centuries, which the Europeans love to utter as the Dark Age. But I don't think that is a dark age, because there was science coming up in other parts of the world at that time. So it is a wrong thing to term it as a dark age. It may be a dark age in terms of Europe, but in terms of the world, it was not at all a dark age, because very good contributions in mathematics, astronomy, algebra was going on during that period. Even medicine was going on during that period, which Europe considers as its dark age. How did that happen? Which country where science was greatly nurtured before the 16th century? Can the students guess the answer? Can any student give me the answer in this audience? Okay, so I am giving the answer, and here is the answer. Not for 1 year, not for 2 years, not for 10 years, for 700 years, the world center of science before Europe's advent was in Baghdad. From 9th to 13th centuries, it were the Arab countries who were the major contributors of science. I will come back to this later in my talk, how this happened. But with all these facts, with all this data, now I come to the theme of my lecture, which I showed you at the beginning. The rise and fall of science. Just as we showed now, USA had a rise. Before that, Europe had a rise and a fall. I showed you, even before that, Baghdad, the Arab countries had a rise and a fall. So there was a rise and fall of science. So it is a historical and a geographic phenomena. Science, just as in history, a dynasty rises and a dynasty falls. The Roman Empire rises, the Roman Empire falls. The Mughal dynasty rises, the Mughal dynasty falls. The Maratha Empire rises, the Maratha Empire falls. In the same way, science has risen in different geographic regions, and it has fallen in those geographic regions only to rise in another geographic region. So the rise and fall is a historical and a geographic phenomena. And that is how we are trying to study in an integrated manner science, history, and geography in today's lecture. History shows that centers of science never stayed static. Centers of science has never stayed static. Science develops at a particular place, then after some time, it shifts away from that place. And that is precisely what we are trying to analyze today. So the question that will immediately come is, which social environment promotes the rise of science in a country? And which social environment impedes the growth of science so that science finally falls in that country? And we shall try to dwell on this aspect in today's lecture. So let us have a long look now into the past. We are dwelling only to recent past. So far we are in the recent past. USA, USSR, before that Europe, before that 700 years of the Baghdad scientific world, the Arabian scientific world. But now we go a bit long past into the other civilizations, more ancient civilizations. Let us see whether this is true even for those ancient civilizations. Hypothesized in a what does a statistician do? He puts forward a hypothesis and then he tests the hypothesis. So we have put forward a hypothesis. What is the hypothesis? The hypothesis is that there is always a rise and fall of science. It's a historical and geographic phenomena, and science shifts away from one place to another. Let us now test this hypothesis to long past. Many thousand years ago, almost 5,000, 600,000 years ago, there was a civilization at Mesopotamia, presently known as Iraq. It was actually a joint civilization covering, as you can see at the center here, there is Iraq, right? And here you can see, if you can read the name here, it has got cut off, Alexandria and Cairo. So Egypt was also a very important center at that time of this civilization. So Egypt on one hand, Cairo, as we all know, is the capital of Egypt today. Alexandria on the seashore was one of the important cities of Egypt even today. And on the right, you can see this Tehran, Iran, and other places, right? Upper side, there is Turkey, and this is the entry point of Europe, actually. So science at that time is not in Europe, many thousand years ago, because this is Turkey and this is the entry point. And science mostly flourished around the Sumerian civilization, centered around Mesopotamia, presently known as Iraq. Mesopotamia, Babylon, and Egypt formed a trio of this civilization, and Egypt was the biggest of them. The left-hand side picture shows Egypt, and basically the right-hand side picture is the picture of today. It is the picture that we have, the map that we have today. It is difficult to read for you from this map, but I will read it out for you. So on the left, you can see there is Egypt, there is this Sumerian civilization, the ancient Egypt, and I have written here the ancient Egypt and Mesopotamian civilization here, right? Here is that same sea, and here is that same sea that you see here today, right? If you continue this direction, you move up to India, because this sea falls into the Arabian Sea. You won't be able to read it, but this is Karachi, the Karachi port here. So the Pakistan starts from here, and after this there is India. So there is the Arabian Sea here. Okay, there is the Arabian Sea on this side. This is Saudi Arabia today. So this is the region where science flourished around 5,000, 6,000 years ago. This was the Mesopotamian or the Sumerian civilization. And I told you the biggest role among these trio of Babylon, Mesopotamia. Mesopotamia is more around Iraq. Babylon is also very close to Iraq, and Egypt slightly offshore in this region. Okay, I have already shown you. So Egypt was the biggest among them. Let us now look into the history of Egypt. Around 5,000 to 6,000 years ago, small groups of people, they were living by the side of Nile, and they cooperated with each other to form a very big civilization. Why? Why did it happen? The students will be answered very quickly. It happened because it was the Nile River, which was the lifeline of Egypt. They could gather their food from cultivation, settling down around Nile. So cultivation, like our country, like India, which is a largely river-borne country, and where we depend a lot on agriculture. Historically, we have dependent. Egyptian civilization was also like that. Cultivation was their main livelihood, as you can see from these pictures. So similar to our own pictures, right? Agriculture was the binding force to form the civilization. As you can see similar pictures in our country also. To retain productivity during drought, they invented methods of irrigation. So they knew irrigation at that time, so many years ago. And then they had to store their grains. And to count the barrels of food, they invented the number system and also the symbols to denote the numbers, which gave rise to arithmetic. So this was the Egyptian contribution to science coming up. So you see these pictures, these hieroglyphic scripts of Egypt, we all know about those, many of which are yet to be deciphered till date. But these pictures give you an idea of the telemarks we use these days in statistics. When we enter into a statistics class, we are taught telemarks, right? These are the hieroglyphic scripts. So they developed scripts to keep account of their crops, and hence literature was born. They had to develop geometry and mensuration to measure their plots after flood. So when Nile flooded them and then receded, then they had to measure their lands, which land belongs to which person. So they had to study. They learned geometry and mensuration through that practical problem. And from there, they went into higher mensuration. They constructed this type of sculptures using 3D objects like sphere, pyramid, or solid polygon. We all know about the Egyptian pyramids. They are the wonders of the world, right? So this helped them to construct huge sculptures. We all know about the pyramids and sphinx in Egypt. To have good prediction about the date of flooding of Nile, when is the flood going to come? They developed astronomy. That means studying the stars. When the bright star Sirius rose before the sun, they knew the flood would occur. So they were watching the sky, they were studying the sky to understand how the Nile may be flooded in near future. And thus Egyptians were the first to create a calendar of 365 days. They charted out the constellations and identified objects, the constellations in star like Great Bear, Pole Star, all these things they studied. In India, for example, we know about the constellation, the Saptorshi, for example, right? So Egyptians were studying all this because they were so related to their agriculture. So they had to study the astronomy, because through astronomy, they could understand the movement of the stars. And through understanding the movement of the stars, they knew which time of the year Nile is going to flood. So they set up their calendar to predict the flooding of Nile. And this helped them not only in knowing agriculture, but it also, studying the stars also helped them to make sea voyages. And Egypt generated a very good fleet, its own fleet of ships, right? This helped them to make sea voyages in future. So this was a great progress that was taking place in Egypt. Looking at today's Egypt, we'll never understand that Egypt was the center of science in the world at that time. All these developments in science took place only during the first 500 to 600 years of civilization. After that, the Egyptian kings ruled for nearly 2000 years. They had power, they had wealth. However, science developed only those first 500, 600 years and not after that. Why was it like that? The Egyptian rulers were powerful, they had a lot of wealth, but the next 1400 years, there was hardly any development of science after those initial 500, 600 years, which I have talked of right now, when they developed geometry, they developed mensuration, they developed astronomy, they developed sea traveling, lot of things they developed, but that ceased after 600 years. So the same question, why science developed so quickly in Egypt? Why science vanished suddenly from Egypt? The answer lies here. Science developed so quickly in Egypt because it was the social necessity. Agriculture was the necessity. Learning the movement of the stars was the necessity. Survival of the people dependent on good crops. Whether you get a good harvest, you'd survive. So you need to ensure a good harvest. So which it prompted inventions and discoveries. So our conclusion to the question, why science developed so quickly in Egypt? Science stems out from social necessity. During the period of development of science, Egypt, then why did it move away so quickly? Now comes the integrated approach to society. Science lies in the society. If the society is conducive to science, science develops. If the society is not conducive to science, science doesn't develop. So what happened in the Egyptian society after the first 500 years that science did not develop any further? Here is the answer. During the period of development of science, Egypt had a democratic, more or less democratic society, not exactly like us today, universal suffrage, parliament, legislatures, court, independent, not exactly like that. But overall, Egypt had a democratic society because it was practicing cooperative farming. The farm, there were individual lands, but they were mostly practicing a cooperative farming, a socialization of land. So there were no all-powerful exploitative monarchs. During these first 500, 600 years, there were kings, but small kings, not all-powerful, very, very exploitative central monarchs, okay? And not only that, in Egypt, women enjoyed a lot of rights. They had many rights in the society. And very importantly, there was no slavery in Egypt. So these are the very important factors that people cooperated. There was a democratic atmosphere. So what does a democratic atmosphere do? A democratic atmosphere enables one to question. If there is a democratic atmosphere, if there's a free and fair society, you can question anything. And questioning is a very important thing for the progress of science. Unless you question, you don't progress. What happened after those 600 years? There was a change in the scenario. There were rise of kings and monarchs, powerful kings and monarchs, the pharaohs came up. And there was a rise of some priests who said that these pharaohs are the representatives of gods. And the priests are the communicators to the god. They can't be questioned. The pharaoh can't be questioned, the priest can't be questioned. So the culture that there are some things which can't be questioned, which are beyond question, came up, which was not there in the original Egyptian culture. And this started hindering science, because the priest's sermon is, do not ask questions about the nature of the world. If you do so, you are questioning the design of the God. You can't ask questions about the nature of this world. Why the plants are coming up, why the stars are there, why the sun is burning like this. No, there's a limit to your questioning, the priest said, because It is designed by the God like that. You can't say, why did the God design it like that? No, that question is not allowed. It is in this way that the inquisitive mind started getting destroyed. And the priest said that if you question like that, then you are committing a sin. And if you are committing such a sin, you will suffer after your death. So people were intimidated. People were made afraid. And freedom to ask questions is the basic necessity for the development of science. As I said just now, once that is taken away, science can no longer flourish in that society. Egyptian science thus ended, although Egypt remained powerful for many years. Now, guess what was the next destination of science after those 2000 years in Egypt? It was Greece. These are the city-states of Greece where science flourished after that. From these, you can see the city-states. You can see Sparta in my map. You can see Athens in my map. You can see Crete in my map. Small city-states comprise the entire Greece. It was such a small area of Europe. So science now shifted. The center of gravity of science now shifted from the Egyptian, Mesopotamian civilization upwards and leftward towards Europe. It was not into a full Europe now, but only Greece. Okay, so Greece came up. This was the Persian Empire has meanwhile been formed here. So this was the division between the Persian Empire and the Greece. There was a lot of war between the Greece and Persia, and there was a lot of war within Greece also. But within that, there was a slow development in science. Two important social persons, two important political persons are responsible for that. One was the great statesman Solon, who started the struggle for democratization in Greek society. He talked about the rights of people, talked about the rights of those who are oppressed. And then arose a statesman 200 years later, whose name was Pericles, who became the king and who actually ushered in democracy in Athens and in some other parts of Greece. And it was this which enabled science to flourish. Because as I told you, democracy, or the right to question, right to interact, right to argue, is a very essential thing for science. So around 1500 BC, world recognized Greece as the center of science. And then a lot of very important scientists came up in Greece. Thales was one of them. He said that matter is the ultimate of science. Everything is born out of matter. You have to study matter to understand science. It is not born by some supernatural thing. It is from the natural thing that this world is born. Hippocrates, today we talk about Hippocrates. Nowadays we are talking about Charak Oath also. So this Hippocrates oath rejected the idea that diseases are caused by the curse of God. He said diseases have to be studied. Their causes have to be studied. It is not the curse of some supernatural being which is causing the disease. So the scientific approach started. Then one after another, great other scientists came, like Anaximander, Xenophanes, Pythagoras. We all know Pythagoras' name. And then came Socrates, who directly told his students, do not blindly believe in the words of your teacher. Always question and debate to find out the truth. Socrates was a bit too progressive for his time, because the politicians at that time were not prepared to take so radical words, and Socrates was ultimately poisoned to death. But Socrates died, but his students continued the reform. Plato was his greatest student. And then other students whose name we know, Aristotle. Aristotle made a sea change to the concept of science. Aristotle worked almost on every branch of science, from physics, chemistry, biology, architecture, everywhere Aristotle contributed. Then came Euclid, then came Archimedes, the great Archimedes, the law of buoyancy, right? Aristocrates. He was the first scientist possibly who talked about heliocentric world. That means sun is at the center and earth is not at the center of our world. Eratosthenes, who measured the circumference of the earth. So all these great things were going on in Greece at that time. However, Very quickly, science again vanished from Greece. And again, the same cold question, why science developed in Greece? Why science vanished from Greece? And again, we'll find answer in their society. Despite the struggle and the reforms of Solon and Pericles, Greek society suffered from a lot of vices. Slavery became a very important part of the Greek society. All the rich men of the society used to have a lot of slaves. And all the slaves had to do all their work, and the slaves had no rights. Women didn't have so much right in Greece. In Greece, the citizens had their voting right. Citizens could speak out against a lot of things, but those citizens didn't consider the women of Greece. And those citizens didn't consider the poor people of Greece. Pericles tried to reform this, but he finally failed. And slowly, the conservatives took up from the radicals. And slowly, Greek society became an authoritarian society with a lot of slavery and lot of hierarchy, where again the reason of the stream of reason lost its way and Greece came down. And now, yes, where did the center of science shift to? Yes, it is our India. India had a long history in science ever since the days of Indus Valley civilization. But that science didn't stay for a long time because those in Indus Valley had to move southwards for a long time, for long distance for various reasons. And then during the Vedic age, there was some development in mathematics and constructive development in various other fields associated with mathematics, but it didn't spread among the people. It stayed a lot within them. Then when did India, that was say from 1000 BC to 500 BC, right? During this period, there were developments, but they mostly stayed within a small section of the society. Mostly the priests and others, they controlled that. But, or the king's ancestors, they only controlled that. But science became a people's movement during the Buddhist era. Because it was the Buddha and Jaina, these two religions actually protested against this stagnation, protested against this stifling atmosphere that was being created. And they actually said that we have to move about. We don't need to stay in one place. We shall move. Paribrajak. This became the champion of the world. And whenever you move, you mix with a lot of people. You get to know a lot of things. And a lot of questions come to your mind. And with the Buddhist monks, the people started moving. The merchants started moving. And with the merchants, the other people also started moving. And interaction started. And we all know that during the Buddhist era, Indian ideas spread to other parts of the world. Today, China has so many Buddhist people. Japan has so many Buddhist people. Thailand has so many Buddhist people. Sadly, the country where where Buddhism was born, it has very little Buddhist people. The reasons are there in history again, but I'm coming to that. So what happened during this Buddhist era? India became a center of learning, a center of science, and it created the first possibly the first university. You cannot say classically that it is the first university because university concept was not exactly at that time, but in a sense, Takshashila was the first university of the world. Then other universities came up, Nalanda. What flourished most fantastically during the Buddhist era was the progress in medicine, Charak, Shushrut, Nagarjuna, Jivak. Medicine and surgery was at its helm at that time. And in fact, all these names are uttered in our new education policy. I will show you later. Charak, Shusruta, Nagarjuna, Jivak, and many more doctors. Why did it flourish so much? Because they relied on experiments. Science cannot flourish without relying upon experiments. Doctors used to dissect the body. They dissected the human corpse with their own hand. Human physiology and anatomy jumped by leaps and bounds. So if you really dissect a dead body, you know exactly where the brain is, what it is composed of, where the liver is, what is it's composed of, how is the liver connected to the kidney, how is it connected to the pancreas, how is it connected to the intestine, everything you know so beautifully, right? So doctors used that. And this liberal atmosphere, science developed. There was great progress in India at the time in astronomy and mathematics also. Aryabhatta, although Aryabhatta may not be one single person, possibly there were a series of Aryabhattas, but this earliest Aryabhatta, who is so famous, we all know about his discovery of the decimal zero, right? That Aryabhatta 475 AD, he developed basic algebra and trigonometry. He proclaimed the theories that the earth rotates about its own axis, and thus he could explain eclipses. And he rejected the concept of so-called astrological concepts like Rahu and Ketu. He scientifically explained how eclipses actually took place. But again, as in Egypt, as in Greece, the politics was changing. The liberal atmosphere of politics was changing from the Buddhist era. Authoritarian regimes were starting to come up. The Buddhist era was coming to an end through domination by Brahminical priesthood. They banned sea voyages. They said it is not right to become a paribrajak. You shouldn't move about. You have to go back to your original days of Vedas, where you stayed within a country, you have to stay within your country. Going across the sea is bad for religion. So when India was moving around to different parts of the world through Buddhism, it was stopped. Said voyages is not good. Then they said every knowledge is in Vedas, while go for other knowledges. And say, like the Egyptian priests, they too said, understanding God's design is beyond the capacity of human comprehension. So then there is no place of science. If everything is God's design, then what is there to know about it? It is designed like that. So there can't be any reason beyond something, right? There is no reason why atom can be broken up, while within the atom there is proton. Within the proton, within the nucleus, there are protons and neutrons. How can so many protons with positive charges stick together in such a small area? There is no reason to seek for this truth because it is designed like that. The science was banished from India. Science, once this type of authoritarian words come up, science gets banished, and again center shifted from India. So where did the center shift now? By 1610 AD, Hazrat Muhammad, through a message, now we are coming back to those 700 years before Europe, the advent of science took place in the Arabian countries, we shared towards the beginning of our talk. So by 610 AD, Hazrat Muhammad, through a message of universal brotherhood, united the splinter groups of nomads of the Arab. The nomads were fighting among them and getting destroyed. Different tribes were fighting within themselves and getting destroyed. Hazrat Muhammad said, we must not unite, we must not fight amongst us, we must unite because there is only one God. So we must unite under one God. And that was his basic teaching. So unite under the splinter groups of nomads to form a powerful kingdom and religion. But how did science come into that religion? This is very interesting. By 750 AD, Abbasid dynasty had its capital at Baghdad, which was within 1800 AD became the world center of science. This miracle was achieved through massive effort in translation. Now this is a great thing. See, already a lot of science has taken place in Egyptian civilization, in Indian civilization, in Mesopotamian civilization, even in Chinese. I'm not talking about the Chinese civilization today. That's another very interesting thing, how Chinese civilization developed. But already there were a lot of things around. There was the Greek scriptures, so many things in science to get. The Arabs, they concentrated on translation. And it is again a fantastic thing that in our new education policy, today we are relying upon translation. We are talking that we have to set up an Indian Institute of Translation Institute, which would translate the various things and spread it among the people, right? So that Arabs became the center of science at that time was first of all started with massive translation. Initially, they translated Persian and Indian works. Later, they started translating from original Greek books. Islam, in its beginning, was a very open system in which rich and poor had equal right in the society. And it was told in the Hadith that understand this world through questions and questions. Sadly, this spirit went off later, as we have seen earlier also. Such spirits promote science. And in Baghdad, The society had no religious bias because many of the translators were contributing to science at that time. And for translation, they invented the discovery of paper came up. Paper mill, the first paper mill came up. Learning some Chinese technology, the paper mill came up. And once the paper was coming up, the translation was becoming easy. Many, like the digitization of today, many translators were Christian and Jews, but they were not repressed. They were respected. Maximum progress was made in astronomy. Al-Biruni's name we all know, but not only Al-Biruni, there were a lot of great Islamic scholars at that algebra, contributing in geometry, contributing in astronomy, they established observatories. They invented the astrolabe, and good progress was made in identifying and curing contagious diseases. Today we are talking about COVID, corona, contagious diseases. At that time, great progress was made in curing contagious diseases in that part of the world, centering around Baghdad. There were government hospitals, imagine at that time, for public use, which were established. The Arab scientists will be ever remembered for their contribution in mathematics. By combining knowledge from India, Greece, Persia, and China, they developed algebra and geometry. This also shows that science has no barriers, actually. You have to take science from various people, from various persons. The Paribrajak concept of the Buddhists, right? 750 to 1050 AD, or these days it is called CE also, is known as the golden era of Arab science. And then its progress was slowly dampened, and then it totally stopped. Again, this was due to political, social reason, as in earlier cases, that the popularity of the Ash'ari school of philosophy came up. This Ash'ari school stated that every knowledge is in Quran. Do not ask questions, because all answers have been provided by God in Quran. Thus, gradually, translation work was banned. Said you don't need to translate, because those books do not have truth. The truth, all truth is in Quran. So, within 13th century, there was a complete demise of science in the Islamic world. Thus, the uprising, the rise of science came in Islamic world. The fall of science also came in Islamic world. From Baghdad, science moved to Europe. The rest of the stories are known to everybody. And I will not tell that story, how Laplace came, how Lagrange came, how classical mechanics came, how Newton came, how James Watson discovered the steam engine, and the Industrial Revolution came, and then the great development took place in Europe that all of us know. And that 300 years of dominance of Europe started after that, right? And they came to India, they colonized us, they colonized other parts of the world. That started a repression also, but within that repression, society went on. So I will not go into that. I'll come towards the end of my talk now quickly with a quick glimpse at the new education policy. So the questions we have addressed are these: why science grows, how science grows, and how science is stopped. This is the question we have answered. Science grows out of social necessity. Science grows only when there is freedom of how science grows. It grows only when the freedom of asking questions is guaranteed and authoritarianism is absent. You can't say this book contains all answers. The king contains all answers. Then science gets stopped. It stops when the freedom is withdrawn. It stops when that freedom to ask question is withdrawn. Moreover, there should not be too much of exploitation in the society. You can't have a slave society. You can't have women oppressed in your society. You can't have lower castes oppressed in your society. Because if there is an oppression, there had to be an authoritarian regime. Because to justify that oppression, you have to set up an authoritarian regime. I'm oppressing him or her. I'm oppressing these people because these questions, nobody should ask these questions, right? It is God's wish. So once that authoritarian regime comes for oppression, for exploitation, science suffers. However, scientists should never be afraid to speak about the truth without caring about future consequences, because they are the champions of science. So even if there is an authoritarian regime, scientists should speak out the truth, as Galileo has spoken out the truth. The chart said, no, the sun is at the center. You can't say earth at the center. Copernicus knew it is earth at the center, it is sun at the center, but the church was saying it is earth at the center. So this authoritarianism was put out. Bruno was burnt alive in this month of February in Europe 400 years ago because the scientist was not afraid of consequences to speak out the truth. Now our new education policy also says that we should have an integrated approach to knowledge. These are quotations from our new education policy. The rich heritage of ancient and eternal Indian knowledge and thought has been a guiding policy for this national education policy. The new education policy is now called the National Education Policy after it has been approved by the cabinet. So it says that the rich heritage of both ancient as well as eternal Indian knowledge. But then one question comes to my mind is that, yes, but what we have seen today, that it is not only Indian knowledge. The Indian knowledge is mixed with the Greek knowledge. The Greek knowledge is mixed with the Mesopotamian knowledge. The Mesopotamian knowledge is mixed with the Persian knowledge. The Persian knowledge is mixed with Baghdad's knowledge. So it's a mixture of eternal knowledge that should always be the guiding policy. So while we are appreciating the new education policy, the national education policy, at the same time, like a true scientist, we are trying to raise questions wherever we find something to talk about. So this is one question. Second, the Indian education system pronounced great scholars like Charaka, Shusruto, Arjabhatta, Barahomihira. These are all written from the new national education policy. Gautama, Pingala, Sankaradev, Maitreyi, Gargi, numerous others who have made seminal contributions to world knowledge in diverse fields such as mathematics, astronomy, metallurgy, medical science, surgery. We have all discussed this, right? Jivaka and others are missing here, but that is fine. Charaka, Shusrutu are there. So all they have contributed to surgery, civil engineering, and this northeast part of this country where you are residing, that is very well known for metallurgical inventions. Smelting of iron is long known in northeastern part of the country, right? In the Khasi Hills and other places. Indian culture and philosophy have had a strong influence on the world. But again, a question comes to me. Not only Indian culture and philosophy, just now we saw Indian science also had a strong influence on the world at one point of time. Today we may be lagging behind, but at one time our contributions were translated. Our contributions were accepted by others, discussed by others, scientists in other parts of the world, right? So our culture, philosophy, and science has also made a strong influence at one point of time. But then one question comes to my mind after reading this national education policy is that something strange is missing in these 66 pages of national education policy. Today we are celebrating the C.V. Raman's discovery of Raman effect, right? But not in one place C.V. Raman's name has come, who won the Nobel Prize for our country in a subjugated India in Britain. We would have loved to see the name of J.C. Bose. We would have loved to see the name of Meghnad Shah. We would have loved to see this picture, third from left, of Shanti Swarup Bhatnagar. We would have loved to the first Director General of the CSIR, right? We would love to see the great chemist Bhatnagar. He was a great chemist, a student of Acharya Prafulla Chandra Rai, another great chemist. We would have loved to see the man on the right, Birbal Sahani, the Indian paleobiologist, who contributed greatly in paleobiology in the world scenario. But strangely, many such names, I don't mention Prashant Chandra Mahalnobish. A little while ago, we were talking about these names also. So post-independence India, the great people like J.C. Bose, M.N. Saha, Satyen Bose, C.V. Raman, P.C. Mahalnobish, Visvesvaraya, Shanti Swarup Bhatnagar, Homi J. Bhabha, why are these names missing? I'm not very sure. But these names should have been there along with the ancient scholars like Charaka, Brahmagupta, Chanakya, Bhaskaracharya, Baraho, Mihir. But somehow it has gone missed. Anyway, we have to incorporate these names. Today we have incorporated in our lecture. So now I will be ending my lecture that Raman did his research in Indian Association of Cultivation of Science. It was formed in 1876 and it is the oldest research institute in India. this name of Indian Institute for Cultivation of Science, Indian Institute of Science, Bangalore, Tata Institute of Fundamental Research, Mumbai, Shaha Institute of Nuclear Physics, Kolkata, Jagadish Chandra Bose's founded Bose Institute of Kolkata, Prashant Chandra Mahalnavish founded Indian Statistical Institute. These also contributed greatly post-independence India. But sadly, again, these institutes are missing. There are references to IITs and NITs. That is fine. IITs and NITs should be referred to. But without basic science, again, the integrated approach, without basic science that has been carried out in Indian Institute of Science, in TIFR, in Shah Institute, in ISI, in cultivation of science, without basic science, you can't progress in technology. IITs and NITs are there for the progress in technology, but this has to be again an integrated approach. Hopefully, the policymakers are keeping this in mind. Maybe it is missing in the 66 pages of National Education Policy, but this definitely. I will end my lecture with what I uttered just now. So we have a National Education Policy, but my spirit of science has taught me that even if you agree to National Education Policy, the National Education Policy has very important things, like I told, translation, a very important teaching in history. It has emphasized on the importance of mother tongue. That is also a very important teaching in history. We have to emphasize on mother tongue. These are very important contributions of National Education Policy. But as a scientist, I have also learned that don't believe everything line by line. You have to find what are the questions even within that. That is why today I have raised some questions even about the National Education Policy, that there should be more emphasis on basic science. There should be more emphasis on the contributions of Shaha, Bose, of Bhatnagar and Birbal Sahani and others, right? Of Homija Bhabha and others, of Mahalnovish and others, of these institutes like cultivation and others. So this is the spirit of science. You don't believe everything in ditto. Even within that, you have to raise questions. And that is what these people have taught us. These two pictures here, the left picture is of Joliot-Curie, the husband of the husband of Madame Curie's daughter, right? And Joliot-Curie was himself a great scientist and won the Nobel Prize along with his wife. Why have I put this picture of Joliot-Curie here along with the picture of Bertrand Russell? Because these two were great champions of this freedom of speech. We have just now learned that no authoritarianism will ever help science. You have to fight for freedom of speech, even in a stifling atmosphere. You don't fear anybody. A scientist doesn't fear anybody. So Bertrand Russell and Joliot-Curie, after the Second World War, they were champions of that freedom of speech. Why? They drew inspiration from Russell-Einstein Manifesto of 1955, which is called the Pagwash Conference. You can see this, Pagwash Conference. And what was it? The Pagwash Conference in 1955, led by Bertrand Russell, the great mathematician, and Einstein, they urged upon leaders of the world to think in a new way, to renounce nuclear weapon, to remember their humanity, and to find peaceful means for settlements of all matters of dispute between them. Now, this was signed by 10 Nobel laureates. There were 11 scientists who signed this Pagwash document in 1955, and 10 of them were Nobel laureates. Now, these 10 Nobel laureates were threatened by their respective countries. USA threatened the US scientists. For example, I talked about Linus Pauling. I showed you the picture of Linus Pauling. USA forfeited his passport. He said, you won't be allowed. If you sign this document, you won't be allowed because we are going for nuclear weapons now. If you sign against nuclear weapon as a scientist, we'll ban you. We won't allow you. We'll ban your passport, won't allow you. But that didn't stop Linus Pauling. His passport was banned, but he went on fighting. And he finally won the Nobel Prize in Peace also, apart from Nobel Prize in Chemistry. This was the person, another person, Joliot. Joliot was a French Communist Party member. So when he was signing, Soviet Union was angry with him. Soviet Union was at Cold War with USA. Soviet Union was also going after nuclear war. They said, no, Joliot shouldn't sign. They put pressure on the French Communist Party. But Joliot didn't yield. He said, I may be a member of Communist Party, but I will not yield on this point. Bertrand Russell was also heckled, but these persons never fell victim to such heckling. So true scientists never fell victim, and this Pagwash conference today is still continuing. See here, I am giving a screenshot from the recent website of the Pagwash. You can see Pagwash statement on war in Ukraine. Even today, there are scientists who are still associated with this Pagwash conference who are saying there should be no war in Ukraine. Both USA, both NATO and Russia should show restraint. Ukraine should remain neutral. They shouldn't go for NATO. At the same time, Russia should immediately stop aggression on Ukraine. There should be no loss of life. Everything, as is written here, should be settled through peaceful means. So we desperately need such champions of freedom of speech among us. Science will flourish in India not only through new scientific initiatives. Science will also flourish in India if we find such champions of freedom of speech among us, who will be good scientists, who will also be unyielding, uncompromising scientists. If he finds fault with the government policy, he should have the guts to fight against the government. So that sort of scientists brought up science in Europe, in USA, in other parts. Einstein, for example, even when he was guarded by USA, after the Jewish repression, when Einstein took refuge in USA in 50s, at that time USA was repressing the black citizens. Einstein, he was a refugee in USA. Even then, he stood in favor of the black citizens against the US government. He was not afraid that if USA sends him to Israel among the Germans at that time, then he would lose everything at that time. But he was not afraid. Sitting in USA under their refuge, he was fighting against the anti-black policy of the government in 1950s. So that is how scientists, we need such people to carry forward the spirit of science. I have taken a lot of time, exceeded my time limit, I think, but thank you for your patient hearing on this auspicious Science Day. Thanks.
Thank you, Professor Kuntal sir, Professor Kuntal Ghosh sir, for your wonderful insight for development of science. He has ignited certain questions: why science developed, how science developed, and why science stopped in some geographical parts of the world. So there we find some possible answers from your from his lecture. That to develop science, first of all, what we need to have a fearless mind, where you can freely question not only the traditional theory. Traditional theory should be questioned and to be proven. It should not be taken for granted. It should be verified by experiments or whatever policy we have. So that reminds me of a poem written by Nobel laureate Rabindranath Tagore. In his poem, he wrote, "Where the mind is without fear, where the mind is without fear and head held high, where knowledge is free, where the world has not been broken up into fragments by narrow domestic walls, where words come out from the depth of truth, where tireless striving stretches its arm towards perfection, where the clear stream of reason has not lost its way into the dreary desert sand and of dead habit, where the mind is led forward by thee into ever-widening thought and action, into that heaven of freedom, my father, let my country away." With this hope, we also believe that we also can compete other European countries, USAs, in development of science. Okay, with this new education policy in mind. So now the forum is open for discussion. If any participants have any questions, they may ask Professor Ghosh. Thank you, sir, once again for giving really a wonderful talk on the topic. So
thank you.
Now the forum is open for discussion.
Thank you very much, Professor Kuntal Ghosh, for your enlightened talk on the rise and fall of science across the globe. It is very interesting and very exciting for all of us to understand how different countries they have they had emphasized and they had risen the importance and given the freedom to the scholars to invent new things. That is very happy. And I believe, that if I understand correctly, the new education policy also, it is a very comprehensive policy which includes all the dimensions of scientific temper, and ultimately, like as mentioned by our Dr. Haldar, so we have to understand basically when we are doing a research, if I understand, we have to understand the basic roots and foundations of human society in general and a specific country in particular. When we link our roots with the global perspective, I hope that way our new education policy mission will be fulfilled. And our country is a great country. It is a highly democratic country, and we all will definitely, as a teachers, researchers, students, will definitely work in the direction where the temper that has evolved over generations, centuries in our country will flourish and flourish, as mentioned by Vivekananda. Let us just go and preach the world about our spirituality, which includes all multidisciplinary, transdisciplinary approach. And really, we have, on behalf of my campus and your university, our Vice Chancellor, sir, and my colleagues, we sincerely express our sincere gratitude for your enlightened talk, and we will have such kind of talks in future, and we'll be sharing and exchanging our views on various areas of intellectual property rights. Thank you very much. Namaste.
Namaste. Namaste.
Thank you, sir. Since I actually in chat box, I got one question, sir, Professor Ghosh, sir, from Dr. Rahul Dasgupta. He raised that why the contribution of the co-author of Professor C.V. Raman was not acknowledged for discovering the Raman effect. Means that the original paper was as I know, that molecular scattering of the light, right? Like that paper was titled. So there, another co-author was also there, who was the K.S. Krishnan, I think. So his contribution somehow was missing. He was the student of Professor C.V. Raman. So if you can enlighten.
See, these are very important questions, and these are very important issues also. Not only this question, there are some. If you go through the stories of C.V. Raman, you will find there are some other important questions also associated with him. For example, there is an allegation that when he was the director of the Indian Institute of Science between 1930 to 1937, at that period of time, women scholars had very difficulty in getting into these institutes. One of the great physicists, one such great woman physicist who couldn't practically get into IISc at that time, later got married to the Nobel laureate Chandrasekhar, and two, three more. Now, what does this mean? This means that this is exactly what I was trying to say, that if nothing is above question, right? Yeah. Somebody can be a great scientist, but there may be some faults in him also. Some document can be a great document. For example, new education policy has very important parts in it. This holistic education, in incorporating various things, the mother tongue, emphasis on mother tongue, emphasis on translation of other different types of scientific things into mother languages. These are very, very important things. But everything falls under scanner. For science, everything. C.V. Raman, he may be a Nobel laureate, but he also falls under scanner. Whether he has rightly treated his student or not, whether he has rightly treated the women scientists of that time or not, or he too had a gender bias like many male scientists often have. Okay, that is not the very discussion today is that we should discuss everything. We should be free and frank about everything. Whether it is C.V. Raman, whether it is national education policy, everywhere we should discuss freely and openly. For example, the thing that I mentioned is that national education policy mentions about HEIs. Now, nowhere is it written what is HEI. You can assume that it is higher education institute. But if you go through the 66 pages, not once it is mentioned what is HEI. Now, why I am saying this is that autonomous research institutes like ISI, Shaha, Bosch, CSIR labs, etc. have been there as HEIs for a long period of time. When the new education policy is talking about forming clusters of this, that may be a good idea. But that may not always be a good idea, because these institutes specialize in certain things. For example, ISI specializes in mathematics and statistics. Bosch Institute specializes in biology. Cultivation, Shaha specializes in physics. Now, these specializations are also important. Holism is also important. You have to maintain your speciality. You have to maintain your integrity. In mathematics, both differentiation and integration, both are important concepts. You can't only integrate without differentiating, right? Differentiation is actually the inverse of integration, right? So in that way, I'm trying to say that we should freely, that doesn't take away any credit from those who wrote national education policy. They gave a very good effort. At the same time, that doesn't take away any credit from C.V. Raman. Right. C.V. Raman has its credit. The writers of national education policy have their own credit. But that is the spirit of science, that nothing is above question. Everything you can discuss, everything you can question, and that will only develop that thing. That will not create an atmosphere of that these things. That is what I tried to say, that everything, somebody said that Quran is above question. Somebody said Ved is above question. Somebody said Pope is above question. All these things created hindrances for free moving, just as you mentioned, Rabindranath Tagore. Into that reason, into that stream of reason we want to flow, right? So that was the spirit of National Science Day, and that should be the spirit of National Science Day. We should respect everybody, but that doesn't mean we shouldn't question everybody. Respect and question should go hand in hand, right?
Yeah. With this, sir, I thank you once again for your deliberation and giving insight into the journey of science, I would say, the journey how science progressed over the decades. And with this, I welcome Professor C.P. Suresh sir, HOD of Department of Horticulture and Forestry, to deliver vote of thanks. Over to you, Professor Suresh sir.
Thank you, Dr. Anindya Halder, Head Department of Computer Applications. It's really a wonderful day and a wonderful lecture we had. Yeah, first it's my prime duty from my heart actually to thank our speaker, Professor Kundal Ghosh sir, from Indian Statistics Institute, Kolkata. There is no words can fulfill my vote of thanks to him. Really, wonderful speech. I was thinking by listening his speech, really, it could have been an offline celebration today in Nahu. But anyway.
How many people are there?
Yeah, sir, it's sir's insights actually. It's only starting from around 80, 90, 100 people are listening, but now maybe around 24. But it could have been a gathering of more than 800 people in our campus.
Yeah, some are joined from YouTube Live. Some have joined from YouTube Live because this is broadcasted in YouTube Live channel also.
Oh, yeah, that's really great to hear. But such a wonderful 1.5 hours might have been useful for many of the people through YouTube. It's definitely. But our campus really missed the full offline, this type of celebration. And such a wonderful speaker. Really, when sir spoke about Mesopotamia, Babylon, Egypt, how the science flourished from there, really, I got goosebumps to hear those things, that type of insights. Really, I'm very fortunate to go through his whole lecture, starting from there to even up to education policy insights also. What is missing, what have to be included, and really it's a wonderful lecture for all, not only for the students or research scholars, is for the teachers. We should not miss this type of lectures from such a great speakers. I think it's very difficult to find such a type of speaker nowadays, and for that I don't know how to thank to Professor Kundal Ghosh sir. I'm very small, I am very junior to him to thank him. But the knowledge what we gathered, the knowledge what we means maybe 30-40 years before, not only 30-40 years before, maybe 100 years before, 5,000 years before also he spoke some of the things to us. That much he learned. Maybe his experience of 30 years he has given in 1.5 hours to us. So that's such a wonderful speech. Sir, I don't know, the words are not enough to thank. I don't know how to thank you also.
Thank you so much. Thank you so much.
On behalf of my Vice Chancellor, my Pro-Vice Chancellor, and the organizing committee, sir, really a great thanks to you, sir, for giving your valuable time. I assure you with our Pro-Vice Chancellor of this campus, he will not leave you, definitely call you offline once to our campus to listen once again a great lecture like this. Thank you so much, sir. Then thank you for all the people who are involved in this program for the organizing such a wonderful speech. The first one is Dr. Anidhya Halder, the coordinator of the program, who really organized nicely, getting a right speaker on this Science Day. And the speech actually really fulfilled the theme of National Science Day of this year. That is integrated approach in science and technology for a sustainable future. If you really once again look through the speech, it is really an integrated approach in science as well as technology. That is clearly fulfilled. I don't know, knowingly or unknowingly, I don't know. Though the total speech really fulfilled the theme of this year. And all got benefited because of this speech, not only the faculty members, the research scholars and students, and the members from other academic institutions also. That's why I thank Anindya Halder as well as all the people, those who attended this program also, I have to thank. And moreover, my Vice Chancellor, who is instrumental to organize this type of lectures on these memorable days, I have to thank because of his enthusiasm. He is the person behind to do these all works in our campus, and he really given a lot of enthusiasm for us to organize this type of online programs also. That's why on behalf of our Pro-Vice Chancellor and the organizing committee, I thank Professor P.S. Shukla sir for being a chief guest in this program, though not able to give a speech because of his preoccupied program in the Nagu Shillong campus, but his all blessings is with us today. Thank you, sir. P.S. Shukla sir also, for Vice Chancellor, for giving your full support for us. Now, I thank Professor G. Singaya sir for really giving enthusiasm for the whole organizing team to organize such an online program today. And he sat from the starting onwards to the end with us, listening the whole program and the whole speech. And he has also given his personal thanks to our great speaker, Professor Kundal Ghosh sir. Thank you so much, sir, for your full appearance in this program and making the program a great success. And not the last, I thank all the members who from the starting onwards attended the program, my students, research scholars, and all the members from different institutions for listening this program with an excellent lecture on this Science Day to integrate the approach of science and technology. And we got the right speaker for that. I thank the Almighty, and I thank everyone who attended the program, and I thank the organizer, and I thank the speaker and my Vice Chancellor and Pro-Vice Chancellor for giving such a wonderful program today to make this program a grand success. Thank you, sir. Thank you, everyone. Thank you, Anindya Halder. Thank you.
Yeah. Thank you. And we do hope that we can organize such events, okay, in Nehutura campus, and that actually will ignite our imagination capacity. We'll get some new direction also to think sometime. And with this, I do believe that with all our effort, we can fulfill our Nehu motto, that is rise up and build. So Thank you. Thank you all, Michael and Kubu.
Thank you. Thank you.
Thank you, sir. Thank you, all of you.
Thank you so much. Thank you so much.
So I'm closing this meeting here, sir.
Yes.
Okay.
Thank you.
Yeah.
अनिंदर जी मैं थोड़ा फुल फ्लो में नहीं थे आज, थोड़ा ठीक है, मैं बोला खराब तो नहीं है, थोड़ा फ्लो नहीं आ रहे थे। नहीं आज बढ़िया बोला नहीं, मेरे को एक्चुअली वो क्या हुआ है, थोड़ा सा टेंशन में थे इसलिए फुल फ्लो में नहीं बोल पाया, फिर भी anyway, I managed somewhat, I managed, but अरे यार मेरे को तो दिमाग खराब हो गया था, ये सब मिस नहीं करना चाहिए था, ये सब ना बहुत बढ़िया इनसाइट्स है यार उसका ये। हाँ ये बाबा ये सब आदमी लोग है ना, इसका तो हम लोग और मेरे को लग रहे थे और आधा घंटा होने से मुझे सुनेगा। नहीं बोर नहीं हुआ, अरे यार कहाँ से कहाँ, everything I listened because I always do that thing and I noted for 2 pages also. Yeah. अरे देखो harder which is नहीं हम लोग जो भी काम है, तुम हो मैं हो, हम लोग ऐसे जो कुछ काम रेस्पॉन्सिबिलिटी हम लोग को बस दिया तो अच्छा करने के लिए कोशिश करते। नहीं अच्छा करने के लिए हम लोग कोशिश करते आगे, ओके हम लोग फुल गिव देते हैं, फुल टाइम देते हैं, ये तो हम लोग का है। जब तक वो कंप्लीट नहीं होगा हम लोग का रिस्पांसिबिलिटी अभी देर में या इवन I didn't left from 4 o'clock to 4:10 to till now from बहुत बढ़िया मींस लाइक ना इतना अच्छा स्पीच इतना कस करके हम लोग को दिया है, तो इसका वैल्यू होना चाहिए। मैं बोल रहे ये तो मैं बोल रहे हाँ मैं तो इसलिए Yeah. That's why I told sir, it is really my words are not enough to say a single thanks because your work for hours because of that. वो लग रहा है वो आदमी का देखे लग रहा है मीन्स द वे he is a really scientist, he is really a person have to be the right speech for a science day। बहुत अच्छा लगा।